I built a heliostat. A heliostat is a device which reflects sunlight from the outside into a room. In my room, it hits a lamp which reflects the light in all directions. To build it, I just took some wooden parts, cut them out, and screwed them together. Then some servos and electronics, and yeah, it works. It reflects the sun to a given point. In this time lapse, you can see the mirror moving while the sun moves. This was about 1 year ago. So here you can see how it works. It rotates, and you can also rotate the mirror. There are some switches and some LEDs to control it. There's a battery and some electronics here. The battery is for the real-time clock, and the controls are to adjust the device. Here you can see how the elevation servo works. I did this lever to enhance accuracy. I tried to put tape in there to run it more smoothly, but it didn't work out so well. The electronics doesn't look so nice anymore. There is some corrosion from the weather. So it was time for a second version. What do I want to improve? So first of all, the accuracy. The old version uses a direct drive servo, so it directly drives the platform and has only the accuracy the servo provides. With my new 3D printer, I designed some parts. A box where everything is dry, stepper motor, gears, some holders. Yeah, and then I put everything together. So this is a prototype, therefore it is so small. I just wanted to test if it works and if this design could be used. So yeah, here we see it. Looks like a prototype. And here we see the final construction. You see the stepper motor moves the arm of the mirror very smoothly. And also the whole platform is moved very smoothly. And since it's 3D printed, everything fits nice together. Yeah, here you can see the switches for the end stop for automatic calibration. After some time designing these parts and printing them, I can start to build them together. So first of all, take the stepper motor and put it in. And you see I have this nice box, so the electronic doesn't get wet again. And the arms are holding here the mirror holder. And this mirror holder parts are quite slim, but I wanted to have it as small as possible, so I don't have additional weight in here. So everything fits together. It's a little bit tight, but I don't want it to fall apart on its own. So I designed it a little bit tighter. So this is how it looks when the mirror is in there. Yeah, it's nice. So put everything together and then we're finished to test. Of course there's also some electronics in there, but I don't show it here. So let's see how it works. So the mechanic works very nicely and the stepper motors can move the mirror in all directions. So here you can see it automatically finds the position and reflects the sun in a given direction. What a nice reflection! So how did I create the software? Usually I would do this on my own, but I thought try ESP Home, which is a home automation software, but can be used for other purposes as well. It compiles the software which can be used in an ESP32 and other devices. It has some modules, one for Wi-Fi, and then you can use the over-the-air updates as well, one for a web server and the time from the network time protocol. Switches and buttons can trigger actions. The sun component returns the position of the sun. The calculation I wrote on my own. Stepper motors can easily be controlled by setting the target position. Overall, it was very easy to program it with ESP Home. I'm very happy with the result. It's a very robust solution. So the time from the web is always accurate. I can control it via the web interface. I can see what it does via the web interface. The 3D printed parts are weatherproof and work nicely. And this is how it looks. So it's on the outside, it reflects the light to a mirror which reflects the light inside. And there it hits the lamp, which reflects the light in all directions of the room in different colors. So it's really fantastic. So here you can see it again. Yeah, the whole room is full of colors. Thank you for watching. I hope you enjoyed this video.